Section 4.7, inverse trigonometric functions. So at the end of our introduction to trigonometry, we're looking at inverse trigonometric functions, which we're going to have to pass kind of a big hurdle to begin with. Remember, for a function of an inverse function, it must be 1, 2, 1. That means it passes the vertical line test and the horizontal line test. Now, trigonometric functions, by definition, pass the vertical line test because they are functions. However, they fail miserably at that horizontal line test because they are cyclical. They're always cycling through the same y values. So any horizontal line is going to hit these trig functions an infinite number of times. Now, we still want to create inverse trig functions. So what we do is we change things a little bit by we say, okay, you know what we're going to do? We're going to take the domain of a trig function, and we're going to take that domain, which is all real numbers, and we're going to condense it down to just a specific set of values where we won't repeat any y values. So that range, which was infinitely large, we're going to take it, crunch it down so that we have just a section of that sine wave, and all these horizontal lines will only hit that section one time. So if we look at y equals sine of x, and then we look at y equals inverse sine of x, or arc sine of x. Those mean the same thing. The inverse notation, sine negative 1x, or arc sine. Both of those mean the inverse sine function. So let's take a look at x and y, and x and y. So let's start at this leftmost end, this minimum down here. That'd be negative pi over 2. And then we'll kind of cycle through these. So negative pi over 4, negative pi over 6, 0, pi over 6, pi over 2, nope, pi over 4, and pi over 2. So then the corresponding y values. This comes from the unit circle. We have negative 1, negative root 2 over 2, negative 1 half, 0, 1 half, root 2 over 2, and 1. So that would be your sine function values. To create the inverse, x and y have to flip. So now, negative 1, negative pi over 2. Negative pi over 4, nope. I didn't flip them. Negative root 2 over 2, negative pi over 4, negative 1 half, negative pi over 6, 0 and 0, not much happening there. 1 half and pi over 6, root 2 over 2, pi over 4, and then finally 1 and pi over 2. So we created a table of values for our inverse trig. Now we're going to go ahead and graph that table and get a picture of what this looks like. So on the x-axis, from negative 1 to 1, there's negative 1 half, there's positive 1 half. On our y-axis, let's go pi over 2 to negative pi over 2, pi over 4, pi over 6, negative pi over 6, and negative pi over 4. So when we plot these values, we're starting down in the lower left, and then we're moving up to negative pi over 4. Negative 1/2. 0 and 0. 1/2. And we connect it with a smooth curve. So what we find is we find this reflection over the line y equals x, and now we have this single piece of a smooth curve that also passes the vertical line test. So the inverse ends up being a function. All right? Now if we look a little more down here at what we have, kind of some properties that we want to focus on. So y equals arc sine of x if and only if sine of y equals x. You've taken the x and y values and you've flipped them around. So what we have to do is we have to remember that we have some restricted values, okay? So the domain of our inverse -1 to 1. Values plugged in must be in this interval. You can only plug in values between -1 and 1 to an inverse sine function. And then right here we have our range. Your answers must fit in this interval, okay? So when we look at evaluating arc sine, now if you think about the unit circle, okay? Let's go ahead and get a sketch of it real quick. Down here, okay, starting here at 0 radians, if you count up, pi over 2, pi, 3 pi over 2. Your answers can only come from negative pi over 2 to positive pi over 2. So that means dropping down negative and then rising up positive. So our answers can only come from quadrants 1 and 4, okay? So when we think about arc sine of -1/2, okay? -1/2, look on your unit circle, where does -1/2 occur for a y value? All right, -1/2 occurs over here at 7 pi over 6. And over there at 11 pi over 6. That's where your y value equals -1/2. So our answer would be 7 pi over 6 or 11 pi over 6. Well, for inverse sine, your answers can only come from quadrants 1 or 4. 7 pi over 6 is in quadrant 3, so we eliminate that. So we take the answer that's from quadrant 4. But there's an additional condition. You have to fall in between these values, negative pi over 2 to positive pi over 2. 11 pi over 6 means you started here and you went through quadrants 1, 2, 3, and into 4. Well, 2 and 3, you're not allowed to cross through them. They are restricted from that restricted domain. So instead, you have to take the shortest path. You just drop right down. So your answer is negative pi over 6. We need the answer from the fourth quadrant, but you cannot pass through 2 and 3, so you just drop down negative pi over 6. inverse sine of root 3 over 2. So you think to yourself, okay, where on the unit circle do you see y values of positive root 3 over 2? Well, that happens in the first quadrant at pi over 3, happens in the second quadrant at 2 pi over 3. So, pi over 3 or 2 pi over 3. But here's the thing, inverse sine can only come from quadrants 1 and 4. 2 pi over 3 is in the second quadrant, so that leaves us with just pi over 3. Luckily for us, pi over 3 also falls in this range, so we have our answer. Inverse sine of 2. Now, where on the unit circle do you see a y value of 2? If you think about it for a minute, you don't. Also, our domain, you can only plug in net values between -1 and 2. So that value does not exist. So that's inverse sine, okay? From quadrants 1 or 4, and it has to fit in that interval, -pi over 2 to pi over 2, so you might have to do some conversions. Well, you will have to do some conversions when you're in quadrant 4. So inverse sine, our range, -pi over 2 to pi over 2, that means quadrants 1 and 4. Cosine, now cosine is your x-coordinate. And x is positive in the first quadrant, negative in the second quadrant. So our range for cosine is quadrants 1 and 2. Your answers can only come from quadrants 1 and 2. Arc tangent from -pi over 2 to +pi over 2. So that's the same as arc sine, quadrants 1 and 4. So, let's take a look at a couple of these down here. So let's look at example A. Arc cosine of root 2 over 2. I'm going to kind of redirect up here so I can write a little more easily. Arc cosine of root 2 over 2. So think about your unit circle. Cosine is x. Where do you see x coordinates of positive root 2 over 2? Well, that would be here at pi over 4. That would be here at -pi over 4. That's where you see x coordinates of positive root 2 over 2. But arc cosine can only come from quadrants 1 and 2. So when we look at those two possibilities, pi over 4 or 7 pi over 4, 7 pi over 4 is in the fourth quadrant. So our answer must be pi over 4. Let's take a look at this second one. Inverse cosine of -1. Now again, inverse cosine has to come from quadrants 1 and 2. So you go to the unit circle, where do you see an x-coordinate of -1? That'd be right here, at pi. Now that's the only place that it occurs. And we see this less than or equal to, so we can equal the pi value. So that would be at pi. That one went pretty nicely. Third example, arc tangent of 0. Now that's quadrants 1 and 4. So you need to think to yourself, where do you see a y divided by x equaling 0? What ordered pairs on the unit circle, when you do y divided by x, does it equal 0? Now that happens at 0 and at pi. So we have two possibilities here. 0, or pi. Well, arctangent has to be from quadrants 1 and 4, from this range, negative pi over 2 to positive pi over 2. Pi is outside of that, so our answer is 0. So go through that process. Where can your answers come from? Find the values on the unit circle. Which ones are going to work for you?